now move to introduce our first speaker, which we are quite happy to have with us, Christian Pohl, is Senior Sustainability Officer at DTU, the Danish Technical University. Christian Pohl has been working as Senior Sustainability Officer at DTU, and he works at the interface between science and society, legislation, commercial activities, and public processes. He has more than 30 years experience, and he has held positions in many sectors, in fact, from academia to private and research. He's mostly focused on the transition toward a more sustainable society, and he will talk to us today about the very definition of sustainability. Christian, if the introduction was appropriate, you shall feel free to take over.
Thank you very much. That was perfect. I will start sharing my screen now. So I think you'll be able to see a green screen now with the DTU. Is that correct? No?
Not yet from my side, but now it's coming.
There, good. Thank you. Well, I've been asked to talk a little bit about how to understand sustainability and how to define it. And that's a topic we work with at the Technical University in Denmark, where I am, as mentioned. First, I would like you to take a look at Mother Earth. The world view from space. I think you all know that picture, and when I look at it, I see a kind of fragile and beautiful world, and we actually like to see it that way. But normally, I would say we look at Mother Earth quite differently, more like this. You know, we see it as a system with some energy input. We have some materials, some fossil fuels, for example, and through our economic subsystem, we degrade the energy quality and we create waste and pollution, and that has actually taken us so far now that we go from the Holocene geological age to the Anthropocene age, where we rule, where man rules in the world. And that has led us into some trouble. So how are we actually doing? Well, this figure is from 2017. It describes the balance between human well-being on the horizontal line and the ecosystem well-being on the vertical line. It is quite clear from the figure that when we are poor and miserable, our impact on the environment is not too heavy. But as soon as we develop modern welfare and consumption-based societies, our environmental impact hit the roof. Actually, no countries are where we should all be in the global sustainable development quadrant to the bottom right. And so first, I'll come back to how we can work with this. I'll first give you a brief introduction to the history of sustainability. We could say we go back to 1972, where we have the first UN conference on human environment. And at that time, it was a growing understanding of the environmental problems, but also a focus on the basic needs of the big population of the world. In 1987, we get the Brundtland Report, and this is where we see the first, you could say, normative definition of sustainability, meeting the needs of the present without compromising the ability of future generations to meet their own needs. That started out a process of world summits in 92, the first. And then in 2000, we developed the Millennium Development Goals and followed up in 2015 with the Sustainable Development Goals and the Paris Agreement. As you can see, the Millennium Development Goals were quite simple, only 8 goals, and with a strong focus on human development, having only 1 goal for the environment. The SDGs, the Sustainable Development Goals, are much more complex, covering the entire world and all sustainability aspects. As such, they are in a way the new definition of sustainability based on the old from the Brundtland report. The SDGs are both technically and politically defined. Many of the 169 targets set specific goals for 2030, while others are less precise, you could say. So there's a need to look at a more scientific model for understanding the state of the world, the state of sustainability. And that was actually developed around 2010 by a team of scientists based in Sweden. The Planetary Boundaries model was developed. That model defines 9 boundaries that in total comprise a description of the environment. Each boundary is quantifying to some degree, and much research effort is put into further understanding each of them better. I think the most well known for you and for most people is the one about climate change, which is politically framed in the Paris Agreement and supported scientifically by IPCC and all the scientists working on the reports from the IPCC. To understand how the approach of planetary boundaries works, I will take you through the logics of translating the Paris goal of not exceeding 2 degrees temperature rise on the next slide. So IPCC has calculated that to stay below 2 degrees, the world must not emit more than 2,900 gigatons of CO2 equivalents. By 2011, half of that was already emitted, and the temperature had risen by 1 degree. Well, the world emits approximately 50 billion tons a year. So with that speed, we have approximately 20 years left. That is from 2011. So 2031, until we need to terminate all CO2 emissions completely. So in order not to get there, we want to lower the yearly emissions. For example, if we halve the yearly emissions to 25 billion tons, we have 40 years in coarse terms, you could calculate like that. But that's for the world population. If we divide that by 7 billion people, and to make it easy, we could say, oh, we want to cut it down to 14 billion tons a year, because then we can divide and find that then we have 2 tons each. An average European citizen of today emits between 15 to 20 tons. So our emissions must not be reduced by 10 or 30 or 50%, but with a factor of 10 in order to stay below 2 degrees. So that's the way things work in a model like this. But a crucial thing is to understand how to allocate. If we take a look at the planetary boundaries, then the green area is called the safe operating space. Within the green area, we are safe if everyone lives within that. The environment is not overloaded, but we are way out of that area. So how to calculate on that? Well, first we need to divide it between the 7 billion people. We can do that by defining the safe operating space, that is the green area of the model, and then divide it by all the people, the 7 billion. That could be done easily by dividing equally, like I just did with the climate example. But there's a lot of discussion of how to divide, how to allocate. You could do it in a number of other ways, but that is basically politics, how to do that. Now, if we then take a person, that could be a Danish person, and look into what he does. Well, one person has a number of needs to be fulfilled, like housing, transportation, and food. And in this case, we look at housing and zoom in on that. If we regard the square of what you could say the safe operating space and the share of that for the house, then we symbolize the size of the house compared to the square as an expression of the impact of the building. So if it's too big, if it's bigger than the square, it's not sustainable. If it's smaller than the square, it is sustainable. And we can actually calculate on that.
Christian, sorry to interrupt. You have approximately 2 minutes left, just to give you time more. Thank you.
Thank you, that fits well. We do that by calculating the life cycle of the house. We can do that. We have a lot of experience in that. And then we compare that to the planetary boundary and the allocated space for the house and the person in the world. So we put that into a graph. Then if it's above 1, we are not sustainable. If it's below 1, we are sustainable. And for this example with the houses, we can see that if we talk about climate change, the houses that we have been looking at calculating shows us somewhere between 2 and 80 times the limits that we should reach. When it comes to land system change, they are okay. They are inside the limits and so on. So my conclusions. Well, if we look at the planetary boundaries model, climate change, biodiversity loss, chemical impacts, land use change, and excess nutrients are all way beyond the safe operating space. We're getting closer to being able to calculate our distance to safe operating space for more and more topics. Only a few topics like the 2 degree in the Paris Agreement are actually operationally operational yet, and all industrial processes emit CO2 equivalents. They emit chemicals, they take up land, and they require farmed input. So it is therefore unlikely that any industrial processed product of today can be regarded sustainable, because that would require being within the safe operating space of all the 9 planetary boundaries. In future, sustainable products may be defined by an agreed share of the safe operating space for each boundary. We are working on that at DTU. Thank you.
Thank you very much for this opening presentation that gives us a very, very broad yet quantitative view on the case. We will be moving on to the next speaker. And please, if anybody has any questions on any of the presentations, write them down, because there will be time to go through them at the end of this event with open questions and answers, and so forth. We are now moving to the next speaker. The speaker being Maria Hayes. Maria is Senior Scientific Research Officer at Chagos Food Research Center. She comes with a solid science background in industrial microbiology and chemistry, as having been active both at UCD and at the UCC later on with her PhD. She joined in 2008 Chagos as program manager for the very interesting project Nutra Mara on marine functional food research. And she has been working extensively on methods for the recovery of food ingredients and biomolecules from marine, dairy, and animal sources. She will be speaking to us today of a very concrete case, that is the utilization of seaweed for the reduction of greenhouse gases emissions. So one specific product in a specific value chain with helping us out on a one driver of sustainability is greenhouse gases emission, which is much dear to the Irish bioeconomy indeed.
Okay, thank you very much, Filippo, for that kind introduction, and to Cliona also for the invitation to speak here today. So I'm just going to give an overview on behalf of myself and my colleagues of the Sea Solutions project. So this project is funded at a European level, and it has 9 European partners. Well, I should say 8 European partners and 1 Canadian partner. And the aim of Sea Solutions is to use seaweeds and seaweed-derived ingredients to reduce enteric methane emissions from pasture-based sheep, cattle, and dairy cows. So the project consists of 7 work packages. There's a management work package and a dissemination work package, but the core activities are things like supply stabilization and characterization of the seaweeds, in vitro assessment of their potential to reduce methane effects and to have other beneficial effects, an animal feeding trial. So we have a number of animal feeding trials actually involving sheep, cattle, and dairy cows. And within this work package, we are also looking at the safety of the end food product, that being milk and meat in this case. And then we have a work package which is focused on the effect of seaweeds on the rumen microbiota, and that's led by Queen's and has participation from Teagas Grange with Sinead Waters there. And then we also have a product development package, because we obviously have to get the seaweed into the animals, and there's a formulation task there that has to be achieved, I suppose, for the project to be successful. Most importantly, and I suppose what underpins it all, and which links very much with today's webinar topic, is the sustainability of the entire process. So we're looking at the life cycle analysis as well at each stage of production of this seaweed product and its administration into cattle, sheep, and dairy cows. So I suppose why seaweed? Well, a lot of the speakers here obviously are big supporters of seaweed like myself, but there is actually a long history of seaweed use as fodder globally. So in places like Iceland and the Mediterranean, in times of hardship, seaweeds were actually used as fodder previously. And of course, there's the North Round Sea sheep, which are known to graze exclusively on seaweed there. But the project was inspired by the red seaweed, which has received a lot of attention in the press, Aspergopsis taxiformis, and its close relative Aspergopsis aromatica. So this seaweed basically has been found in studies carried out in Canada, in New Zealand, and in Australia to reduce methane emissions by over 98% in some instances when the seaweed is included into the diet of the animal at a concentration of between 1% and 4%. And in some instances, even as low as 0.5% inclusion of the dry matter of the total animal feed. So that all sounds great, but there are caveats, unfortunately, with that. So one of the main caveats being that cultivation of Aspergopsis species at large scale is thought to have a negative impact on the ozone layer. But more importantly, and what's been known for maybe 30 years or more now, is that the active component in Aspergopsis is bromoform, and this is a known carcinogen. It also has impacts on palatability of the seaweed for the animal, and the cost of actually using this seaweed in Ireland, for example, in my opinion, and in the opinion of some of my collaborators, is prohibitive currently, because it's not a native seaweed to our waters, and therefore it would have to be imported. So, you know, when you take this all into account, it's not a seaweed that we felt we should focus on within the project. So what did we focus on? So we focused on nearly everything else. So to date, we've screened, I would say, well over 150 seaweeds from Atlantic waters and Pacific waters. And we have stabilized these using the flow of activities I show here in the lab. And we're focused on bioactives such as fluorotannins, which are known to have a positive impact on animal health as well when included in the diet at concentrations between 1 and 4% of the animal. They're known to be anti-emetic, for example. If they're included at too high a concentration, they can be anti-nutritional, but you know, in formulations where they're included correctly, they actually have a very positive and beneficial effect to the animal. We're also looking at things like lactic acid bacteria that are on seaweeds, lectins, saponins, and proteins and peptides as well. But underpinning all of our selections, I suppose, would be primarily the cost and availability of the seaweed, the indicator bioactive, of course, the efficacy in the in vitro trials and the in vivo animal trials, and then the content of bromoform and iodine, because these present problems if you're developing a seaweed as a feed ingredient for animals in terms of legislation. So within work package 1, we're, as I said, looking at things like fluorotannins, which are polyphenolic in nature. And I just show here a schematic of how we go about extracting the tannins from the seaweed and quantifying their amounts. We're looking at iodine, so we have a quick, convenient, non-radioactive method to determine iodine content. And in all instances, we use Asparagopsis as a control because we know already the iodine content of that seaweed, and we also know that it's a good methane inhibitor. We are trying to enhance the seaweed, I suppose, in terms of palatability to the animal. And to achieve this, we've been using methods such as hydrolysis and fermentation as well, because these are known to enhance, you know, the sensory attributes of the seaweed and make them more palatable to the animal. So I just show here, for example, this graph shows an in vitro antimicrobial assay that we set up at Ashtown, where we've used the methane producing bacteria Methanococcus maripolis, and we've tested different extracts that we've isolated from brown seaweeds and assessed the antimicrobial activity of these extracts against this particular bacteria. And as you can see, nearly all of the extracts that we've developed have had a very positive effect on this bacteria. So this would be an indicator, I suppose, that we should pursue these tannin extracts as potential anti-methane ingredients. So once we've isolated and characterized our extracts from the seaweeds in question, we then formulate them into feeds and we test again in vitro using an artificial rumen. And this system is known as a Rusitech. So it simulates the rumen of a cow or a sheep or any ruminant. And it basically, we can assess the impact of our seaweed extracts on the different bacteria that are present in the rumen. And most importantly, we can measure the gas emitted and the methane emitted in the presence and absence of our seaweed or seaweed extracts in question. So now, as you can see then, following the Rusitech analysis, we then carry out our actual dairy trials, beef feeding trials, and sheep feeding trials. So to date, we've screened about over 74 seaweeds and extracts to date. We've characterized them. And from this 74, we've identified 2 seaweeds and 3 extracts that show potential to reduce methane in vitro. So these seaweeds have gone forward to sheep trials that are being carried out in Teargthe Grange and Athenry, I should say, very importantly, and also in Nibio in Norway. At the start of May, we're beginning a beef feeding trial in Teargthe Grange. The seaweed and the extract are being prepared in Teargthe Ashtown. And in September, there is a dairy trial in SLU in Norway. And there is also a small dairy trial in Afby in the north. And currently FLI have just completed a dairy feeding trial with an Irish seaweed and seaweed extract. And we're awaiting the results of the analysis from that trial currently. So if I just present here briefly some results that we obtained from our sheep feeding trial in Athenry. So we used a brown seaweed and an extract from a seaweed, and we included these both independently at 4% of the dry matter in a ration that sheep would normally receive. And we noticed that there was a greater than 19% reduction in methane with the extract and about a 10% reduction with the whole seaweed. So you might think, okay, that's a far cry from 98% inhibition that you see with Asparagopsis, and it is. But if you compare it to products that are on the market currently, such as Trinop, or direct feed antimicrobials, you're seeing with those inhibition in around 10%. So our extract shows promise really as an ingredient to reduce methane emissions. So this is just an outline of how the actual animal feeding trial was carried out. So it was carried out over an eight-week period where the brown seaweed was included at 2% and the extract at 4%. And we also included other additives in another trial, such as soya oil, which had shown promise previously as an anti-methane ingredient. But in this instance, we actually saw a less reduction with this combination approach than we did with the extract directly. So at our partner institute then in Nibio up in Norway, they are looking at another brown seaweed up there. It's different to the Irish one. It's harvested from Norwegian waters, and they carried out a sheep trial in 24 lambs, 12 are female and 12 are male, and they fed the lambs a diet of grass silage and concentrate with or without our algae. And then different measurements were taken, including feed intake, greenhouse gas emissions in the respiration chambers, weight gain was assessed. Then samples of rumen fluid were taken for analysis in work package 4, and the iodine and nitrogen digestibility was also assessed. So there was positive seen in this study as well in terms of the growth rate of the animals. There was a higher growth rate for the animals that were fed the seaweeds. And in terms of the greenhouse gas emissions data, I have here that it's not analysed yet, but at our meeting in March, we did present results and there was reductions in the region of 8 to 12% observed with this brown seaweed as well. So as I mentioned already, the dairy trial at FLI is still ongoing. It started in February. It's just completed recently, and we're waiting on the analysis of these results. So Cliona had asked me at the start of this talk whether we were looking at the quality, meat quality or dairy quality at the end of the trial. So we are looking within this project at the impact of the seaweed ingredient on iodine, for example, in the end food product and in terms of food safety. And we are obviously measuring, doing nutritional composition analysis on the end products as well. So that analysis is being carried out at Chog's Ashtown. So the group in Germany are sending dairy samples to us to analyse for iodine, heavy metals and the different nutrients in the end food product as well. So within work package 4 as well, our Canadian partners and our partners in AFBI and Queen's in Northern Ireland are looking at, as well as Sinead Waters in Grange, I should mention very importantly, we're all looking basically at the effect of the seaweeds on the rumen microbiota. So in the study carried out with seaweeds from the Pacific that the Canadian group are looking at, there was a noted kind of prebiotic effect of several of the seaweed extracts, you know, and some of the seaweeds also had an effect on their archaeal methanobacteria found in the rumen normally as well.
Maria, just interrupting you, there's about 2 minutes left in the time.
No worries. Thanks, Lena. Okay, and then within work package 5, we're looking at developing a feed ingredient. So we actually did this initial work at Ashtown, and we assessed the impact on processing if we were to make a pelleted product for an animal on our active in question, and in this case it was tannin. So unfortunately there was an impact on the feed ingredient when we included it and processed it at the temperatures that are normally used in a feed production plant. On our active. So we saw a marked decrease in fluorotannin content in the end product, but not with feed 3, which is we used a different process to make this feed. So the fluorotannin remained active in feed 3. Then in SLU, the actual cost analysis or the techno-economic assessment and the life cycle analysis is being carried out by Frederick and Sophie in SLU and KTH in Stockholm. And we've been very active in dissemination activities as well within the project. And just to wrap up, I suppose, I hope people will have some questions for me at the end of this, but just to thank all the team involved in Sea Solutions, and here they are presented. And I'd like to thank you all very much for your attention.
Thank you very much. That was very interesting. It's a nice example of a conjunction between marine resources and land resources. So the blue bioeconomy bridging on both sides of the shore. It's a good way to move on now to the next speaker, which in fact is two speakers. So a brief introduction on Paulino Donohoe and Jamie Downes. Jamie Downes holds a PhD from Galway Mayo Institute of Technology and has over 15 years of experience in aquaculture, and both in terms of research and regulation. Paulino Donohoe has been involved in aquaculture as well for quite a while, since 1999. She holds team leader position at Marine Institute. I will be going a little bit faster on your introduction because there is the two of you. So I immediately introduce the topic of your presentation. As both representative of the Marine Institute, you will be presenting to us actions on growing sustainable seafood.
That's great. Thank you very much, Filippo. And just to say, unfortunately, my colleague Jamie Downes has been called away unexpectedly, so I will be giving his presentation for him. So let me begin by saying thank you very much, and thank you to Cliona for the invitation to be part of this webinar. So I want to talk to you today about sustainable seafood, and I will present two ways in which the Marine Institute are researching this at the moment. One is integrated multi-trophic aquaculture, which is IMTA, and the other is the use of recirculating aquaculture systems. So to begin with, I'll start with integrated multi-trophic aquaculture. So integrated multi-trophic aquaculture is a term used to describe this concept in aquaculture, and it's not new. The acronym was coined by Thierry Chopin at a conference in Canada. Most current aquaculture practices, as you know, are single monoculture practices, but the addition of other species to production systems is known as polyculture. And IMTA is a specific type of polyculture which requires growing two or more species, and for those species to be linked to each other, serving complementary functions within the ecosystem. The term integrated is the key element. This idea is that inorganic and organic waste from one species serves as nutritional inputs for other species. This waste is used as nutritional inputs, reducing or eliminating the waste, as it is now a useful co-product. In Europe, the current aquaculture practice is predominantly single species monoculture. Once species are farmed on site, adding another species creates a polyculture production system, and IMTA produces a restorative farming setups which can be run safely and efficiently to reduce environmental impacts and to optimize the use of space. They provide product diversity on the farm and create alternative revenue streams for the operator. The species being farmed are complementary, deriving benefits from the arrangement, and the setup is advantageous to the environment and the farm. There is no ideal IMTA system. It is a concept that can be applied to specific scenarios. IMTA opens up the concept of nutrient trading, putting a value on the benefits of these extractive species. And IMTA can be carried out in differing types of aquaculture systems, including open water and closed flow-through land-based systems. So here in Ireland, we are carrying out research operated by the Marine Institute. We have an open water IMTA system at our site in Lehanapool in Connemara in Bertaboy Bay. This site consists of 21 hectares of aquaculture licensed site. It is a pilot scale site, and it approximates to about a quarter the size of a commercial farm. Its design is focused on enabling IMTA species to be added to traditional aquaculture sites, and we have recent moves to high resolution and real-time monitoring. We have recently added a bespoke low trophic grid designed and installed strategically on the site, and we have enhanced decision support and environmental data to manage the site. So the species and the interactions on site. So as our fed species, and these are the species that input nutrients into the system, So we have Atlantic salmon, and then in conjunction with these, we have lumpfish used as cleaner fish to combat sea lice infestations. We also then have the extractive species. So these are the filter feeders which take out the particular wastes, and these are seaweeds which absorb the dissolved minerals and carbon, reusing the waste from fish entering the environment. We also have oysters, scallops, the black scallop, which is locally known as the clochine, and seaweeds, and these include Saccharina latisma and Alaria esculenta. We also are looking into novel species, and these currently that we have on site at the moment are urchins, and these are fed directly from the seaweed we produce on site, which enhances our circularity. We also have lobsters, which are utilizing the waste from the fed stock, and this is how we have incorporated the IMTA system at the site currently. The main focus for our research at the moment is through the Astral project. The Astral project is made up of 5 IMTA labs across the whole of the Atlantic Basin, and this is in accordance with the Belém statement. The aim of the Astral project is to develop new and sustainable, profitable and resilient value chain for IMTA. So we have IMTA labs in Ireland and South Africa, Brazil, Scotland and Argentina, and these are a mixture of open water systems and land-based systems. So in the project, we're striving to look at the feasibility of cultivation methods for these new species and new production systems. We're looking at infrastructure and the technologies and how these can be advanced to particularly encourage the use and the research into IMTA. We're looking at the growth constraints and how we can strive towards best practice with regard to IMTA. And this project will demonstrate IMTA as a suitable, sustainable approach for the aquaculture industry in the future. So the challenges that we face with regard to IMTA are largely economic and regulatory. Generally, an imbalance between income and between the trophic levels discourage the adaptation of the concept. Other trophic levels in an IMTA setup add complexity to farm husbandry and infrastructure, and it also increases costs and effort. And farmers are familiar with their current systems, and change is always unattractive and can be risky. However, oh dear, what's going on? Sorry, my slide doesn't seem to want to change. Oh, okay, there we go. So the benefits of IMTA, and these we would hope as research progresses and IMTA is taken on by the industry, will improve the uptake of IMTA. So these benefits include the achievable, sustainable production of secure seafood. They provide waste and reduction services to the industry through bioremediation. They reduce ecological impacts, and they add to the value of the ecosystem services of the production systems. They shift the focus to a more circular system, and they allow the co-location always allows better value aquaculture, of the better use of aquaculture space. So that brings my presentation to a close with regard to integrated multi-trophic aquaculture. And unfortunately, my colleague Jamie had to step away. So this he would be presenting this portion of the talk and on recirculation aquaculture systems. So recirculation aquaculture systems are systems in which water is reused after undergoing treatment. It allows for complete control of environmental parameters and increased optimization of production. Where water exchange is limited, a number of treatment steps are required. Biofiltration is required to reduce ammonia toxicity, and mechanical filtration is used to remove the suspended solids from the system. Other types of filtration and environmental control are often also necessary to maintain the water quality and to keep it clean, and to provide a suitable habitat for the fish. And these include the sterilization, and the techniques used there are the use of ozone or UV. At times there is necessity to add oxygen into the system, and there is a need sometimes to degas carbon dioxide. So the challenges to the Ras systems, as recognised at the moment through the research that Jamie has carried out, sees that the system designs, 50% of the Ras companies have had to rebuild or redesign their systems. A system with fish and waste runs completely different to an empty system. You require a skilled labour force, so biologists becomes engineers and chemists. There is a need to constantly monitor your water quality. Also, mechanical problems arise very frequently due to perhaps equipment performance. There's a significant cost in the investment, and yes, there are energy requirements, and this can be very expensive also. The opportunities are the development of specific training programs for Ras management and to grow aquatech sector, developing solutions to increase the efficiencies. So the benefits of Ras. It can be an intensive production system compatible with environmental sustainability. It reduces the need for fresh, clean water while still maintaining 80% of a healthy environment for the fish, and this can be up to 85% less. Improved opportunities for waste management and nutrient recycling, and these include low rates and high concentrations provide easier opportunities for greater treatment of effluent. The opportunity for waste valorization, such as sludge, to be used as fertilizer, and there is a link to IMTA systems. There is also greater hygiene and disease management capabilities within a Ras system. There's also the minimized food conversion ratio, the FCR, due to optimum growth conditions. So this provides for a larger reduction in environmental impacts of aquaculture systems, consisting in minimizing the FCR. This allows for additional benefits in cost savings and allows for a 20% reduction in Atlantic salmon production. So the sustainable system increases the time taken for the production system. So it ensures sustainability while creating future growth with the added benefit of improving the environment impact. And you can see here that within the Ras system, the production can be, there's 3 sets of production within the system as compared to the conventional production over the same time period would only have 2 production cycles. So recently in our facility in Newport, there has been an upgrade of an old hatchery to include the Ras system where this research has taken place. So this upgrade took place in 2022, and this system can now produce up to 2.5 tons of salmon smolts. There are 8 tanks, 5.5 cubic meters with water treatment and drum filters, a bio tower, a degassing tower, UV and an oxygen cone as all part of the system. The project that is being headed up by Jamie and his team is Samson Smolt, and this hopes that to develop Ireland's, it has set up Ireland's first recirculating aquaculture system for Atlantic salmon research. It investigates the performance of the system, which includes looking at water quality, usage, energy. It utilizes potential benefits to increase the overall size of Samson smolt in Ireland. The production of more robust smolts and the investigation of fish performance and welfare are being investigated. And it's looking to increase the production capacity of hatcheries and the sea sites. And a key baseline ensuring the development of Ras technology is that it is compatible with organic standards. So there has been some great success with this project to date. The production itself has produced excellent growth throughout the freshwater production phase, and fish have been transferred to sea just in the last week. There has been large growth increases seen both in the FCR and the Pacific growth rates. So with the Ras weight of 288 grams and 347 grams for the different stocks, as compared to the flow-through system, which is the normal production system for the hatchery phase of salmon production. You can see that it compares to only 90 grams to 100 grams for the corresponding stocks.
Pauline, just interrupting you there for the 2-minute warning. Thank you.
Okay, perfect. I'm near the end now. So also as part of this research, all the fish reared to date have been part of the organic, have had organic certification, and this will add to the favourability for the industry. So some of the opportunities identified and the growth. So the Irish industry can take advantage of significant overall efficiencies of the Ras system to increase smolt size before transport to sea, and the additional benefit will enhance productivity at sea. The Seafood Task Force identified that international linked trends of producing larger smolts and the need for the Irish industry to develop this capability for resilience and competitiveness. And in general, the RAS results in efficiencies, both biological and financial for the industry, reducing environmental impact, increasing productivity, creating efficiencies, and increasing sustainability. So thank you all very much. And there are contact details there for myself and Jamie. Jamie, unfortunately, isn't here, as I said, and he will be able to answer any questions, and I'd be happy to answer in any questions on the IMTA systems. So thank you all very much, and I'll pass you back to Filippo now.
Thank you very much, Pauline. Much appreciated, both detailed and easy to follow. I'd also like to take the chance to remind the audience that this presentation also comes from a very extensive experience in Irish and European project. Pauline has been active on the Astral project, on the Tapas project, as well as she's an authorized officer under Fishery Acts and a compliance officer for health product regulatory approval in Ireland at the Marine Institute. So it's an extensive experience which I have not managed to fully cover in my introduction at the beginning, but her and the other speakers are quite an impressive panel. Before we move to the next speaker, who will be presenting in a little bit different format, due to logistics constraint, I will introduce him. We are speaking of Stephen Cornack, Project Executive Officer at IRBEA. IRBEA is the Irish Bioenergy Association. It's a reference for all appertaining bioenergy and related topics. We are glad to interact with them whenever possible. He has been also active in the Northwest Europe Project 3C, and he will speak to us about a topic that bridges land and sea in maybe a way that not everybody would think of. Okay, so he will speak to us through a recording of the topic of biochar and the marine, exploring the potential of interaction between biochar, which one associated with a land product, and the marine. So looking forward to listen to his presentation there.
Okay, hello to all. First of all, I'd like to begin by apologising for not presenting in person myself today. Unfortunately, it couldn't be avoided, so I hope you'll accept my pre-record instead. Second of all, I'd like to thank Cliona for the invitation to present to you on this interesting topic and webinar, the topic of the blue bioeconomy and greening the marine. So my own name is Stephen McCormack. I'm Project Executive with IRBEA, the Irish Bioenergy Association. I have a background in energy sustainability and environmental science, and I've ended up working in a role that encompasses all of these three sectors. So that is the production and use of biochar for various different applications. As you'll see, biochar neatly straddles the fields of bioenergy and the bioeconomy. And just before I begin, a bit of background about IRBEA. So we were founded in 1999, and we are the representative voice for the bioenergy sector here on the island of Ireland. We're a membership organisation with a diverse range of members, basically anyone with an interest in the bioenergy space. We cover the areas of biomass, biogas, biofuels, biochar, wood fuels, and energy crops. We're involved in policy, lobbying, and advocacy on behalf of our members in various different sectors, and we're largely funded through membership contributions as well as a number of research and demonstration projects. These include the administration of the WFQA, or Wood Fuel Quality Assurance Scheme, the European Innovation Partnership Project looking at small on-farm biogas demonstration, a Just Transition funded project looking at bioenergy business development in the Midlands, and then finally the 3C project, which I myself am directly involved in. Now, if you're interested in finding out more or becoming a member, I'd encourage you to visit our website at irbea.org. So 3C. First of all, it stands for Creating the Circular Carbon Economy. And it's an Interreg Northwest Europe funded program which sees 13 project partners and sub-partners over the 6 participating countries of Germany, Belgium, France, Netherlands, Wales, and of course Ireland. It's been led by the University of Kassel in Germany, and the aim is to assist and support individuals, SMEs, and startups looking to develop innovative biochar-based products and services. We recently finished up a professional development course to support biochar entrepreneurs, which saw a diverse mix of participants representing the agricultural community, foresters, biochar producers, technology providers, municipalities, water companies, and even artisan food producers, all looking to see how they might develop their own biochar-based businesses and services. Now, we'll hopefully be running this again later in the year for new entrants, and so do get in touch if you'd like to find out more. Now, that's just a bit about the 3C project. We'll now look at some of the logic behind focusing on biochar production and use, very much a sector in development. So we start at the beginning. What exactly is biochar? So in a nutshell, it is a black solid material with a high carbon content, which can be made from a wide variety of different biomass streams, everything from wood chip to food waste to grassy fibrous material, and indeed marine-based biomass. It is a product of what we know as pyrolysis, a thermal conversion process that involves heating the biomass in the absence of oxygen. It is produced in a manner similar to how charcoal is made. A biochar and charcoal can be distinguished by the virtue that charcoal is for burning and the provision of heat, whereas biochar is destined for uses other than burning. However, depending on who you talk to, you may hear many different names which are used, such as renewable carbon or indeed biocarbon. Biochar is often a candidate for substitution for traditional activated carbons used in filtration applications. An activated carbon can come from biomass such as coconut, but more traditionally it comes from coal. By its nature, it's highly porous, meaning it has a large amount of pores on the surface, similar to a sponge. And it's often described as being recalcitrant. So what that means in effect is that as a material, it's extremely stable and degrades very slowly over time. It can be variable in shape and size and typically gives rise to a slightly liming effect. Now pictured here, you'll see a few different before and after pictures of different biochars. Now before I continue, I thought I would put this slide in to show you that there are a number of different parameters, techniques and equipment choices that are suitable for making biochar. Now they vary in size, throughput, operating temperatures, continuous or batch mode, and indeed varying levels of yield and carbon content. A picture of just a few of the many different types of kilns or retorts available and in use for biochar production. These range from low tech to high tech. Now for marine-based resources that contain a high moisture content, HTC or hydrothermal carbonization would likely be the choice, and the char that is produced is often termed hydrochar. But more usually for terrestrial biomass streams, the biomass needs to be pre-treated or at least to have a lower moisture content. Now the thermal conversion process, so when the biomass is heated in the absence of oxygen, it results in the biomass releasing a combustible gas and bio-oil. Now these can be used to sustain the reaction, they can be stored, or they can be combusted for the provision of heat. And so the process can actually give rise to large amounts of usable heat, which can and should be put to good use. So whether this is for process or district heating, for example, the phrase combined heat and biochar is often used to describe these setups. In some cases, they can be utilized to provide carbon negative heat. That is a useful source of heat and a carbon sink in the form of biochar. Now, to gain an understanding of why biochar is so useful in so many different applications and situations, as I said, it helps to think of it as a very stable black sponge on the microscale. And if you were to image it using microscopes, you would see something like the picture set in the center here. As you can see, it's full of pores, nooks and crannies, or micro, macro, and mesopores. And this in effect means it has a large surface area. As a result, it can provide a habitat for soil bacteria and fungi to colonize. Another key aspect of biochar is its cation exchange capacity. It's a key property that is central to environmental applications and one that is based on charge interactions between positive and negative charges. And these properties are what leads to the retention of soil nutrients in soil amendments and indeed the removal of certain pollutants in odor or water filtration applications. They can bind to heavy metals, for instance, and immobilize them. It can in fact absorb a wide variety of different substances. Now, due to the thermal conversion process, biochar becomes extremely stable and will not degrade over time in the same way that the parent material would have, whether that's through decomposition or through microbial action, for instance. This means, in effect, that the carbon is stored for a long amount of time, so anywhere between decades to hundreds or even thousands of years. And as a result, it can sequester carbon, assuming that the material is not combusted. Now, a useful rule of thumb for every unit of terrestrial biomass derived biochar, on average, is equivalent to 3 units of CO2. This figure is slightly different from marine resources though. So it can be extremely useful as a material. My time is limited here, so I just wanted to touch upon very briefly just some of the sectors in which it's finding uses. In the agri sector, it's been used as a slurry additive to reduce odor and increase carbon content of the material when it's land spread. It's been used in animal feed additives and as an animal bedding material. It's used to reduce nutrient runoff into watercourses. It's also showing promise in reducing eutrophication incidents through the use of biochar socks and pontoons placed in streams, ponds, and lakes. The EU organic fertilizer regulations have made provisions for biochar-based organic fertilizers. Biochar is also finding new applications at the planting stages of forestry. This could be especially useful and beneficial in nutrient-poor soils. It can be added to composting processes to make a carbon-rich material and to reduce emissions. Some biochars may prove suitable for treatment of water quality. Biochar has also been incorporated into soak pits and percolation areas for domestic septic tanks as filtration medium. It's also been incorporated into suds, swales, and constructed wetlands alongside transport and housing networks, bioinfiltration ponds, rain gardens, green roofs, and so-called structural soils. Biochar has also been used to remediate heavily polluted sites, including former mines or indeed brownfield sites where heavy metals can give rise to concern. Biochar can bind to these heavy metals and immobilize them, preventing further loss to environment. It can also help in the revegetation efforts which prevent further runoff of the contaminated soil into local watercourses. It's also featuring predominantly within the horticultural sector. Now, there are a growing number of commercially available horticultural products available from all corners of the world. For horticultural applications, the biochar is better premixed with beneficial organics, and these can range from beneficial bacteria to seaweed blends, worm casts, mycorrhizal fungi, manures, mineral fertilizers, and even frass, an insect manure, which has the added benefit of preventing damage by pests. Now, biochar and compost blends are being sold as peat moss replacements. There are also liquid biochar blends, which can be applied with traditional spraying equipment. Biochar, as I mentioned, is being used as green roof substrates. And many of the commercial biochar containing soil products contain seaweed fractions. Another interesting Interreg project called Horti Blue Sea has been exploring the potential for soilless growing media for commercial horticultural operations, with trials incorporating chitin and biochar and growing tomatoes and strawberries. They have a nice series of free to view webinars and fact sheets on the results available on their website there to find out more. Now, while agri and environmental applications are often the focus of biochar discussions, recent years have seen the attention shift towards the use of biochar within materials. There are companies making thermoplastics, concrete and tarmac or asphalt containing biochar, turning any resultant products made from this material into possible carbon sinks. I've heard other biochar practitioners refer to the whole process of biochar production and use as reverse coal mining, which is a really nice way to think about it. Now, while the vast majority of the commercial operations or current commercial operations involving biochar are focused on terrestrial sources of biomass, so whether they're wood chips, fruit stones, or agri residues, recent years have seen a surge in research into the potential of utilizing marine biomass as a feedstock. There are a growing number of publications looking at the valorization of a wide variety of micro and macroalgae species and their component parts, shellfish, and indeed seafood processing residues. Now, recent scientific research publications have been looking at the potential of producing not only biochar, but other carbonaceous materials from marine resources. Now, the techniques vary across the literature, and many of the biochars produced, at lab scale at least, produce biochars surface areas far in excess of those being found in high-end commercial activated carbons. And these biochars are being examined for their ability to filter water, remediate contaminated sediment, to bind to and immobilize pollutants. But other promising applications are also being explored, such as the production of graphitic sheets or carbon nanotubes, whether these are for use in electrodes, energy storage applications, or indeed biosensors. Now, the image there from the bottom is from researchers at UCC Marai, and it's only just recently released. And they've explored the potential of a seaweed biorefinery concept, producing valuable compounds and a hydrochar from Laminara digitata, with some interesting results, including hydrochar with a really high calorific content. I would encourage you to have a read of that, and it can be found in the Chemical Engineering Journal. Actually, it's worth noting that another paper they released late last year explored the theme of enhancing methane yields in anaerobic digestion through the addition of biochar made from whiskey draff, so a byproduct of the whiskey production. And so it's great to see continued research of bio and hydrochar being carried out in Irish universities and research centres. Now, many of these research topics will involve pre or post treatment of the biomass. So whether that's the addition of other compounds, doping the biomass, pre-carbonisation, or the use of acids, for example, to activate or increase porosity. Now, this leads me to the idea of designer biochars or engineered biochars. So that is biochars that have been enhanced so that they're better at doing the job that you want them to do. Now, another recent publication, this time exploring the use of shellfish waste for biochar production, such as crustaceans and bivalves. The paper concludes that engineered biochars are capable of effectively eliminating various contaminants, such as heavy metals, antibiotics, and excessive nutrients present in aquaculture wastewater. Now, anyone who has experience in keeping fish at home will have likely encountered activated carbon filters for purifying tank water. And the right biochar can, of course, do this job. And indeed, there's research into how biochar might be incorporated into land-based aquaculture operations for the reduction of ammonia within the water circulation systems. And of course, depending on your source material and processing techniques, you will have biochars in powdered, granular, or pelleted form, so similar to commercial activated carbon. And so the selection of the right biochar for what you want will increase your chances of it being successful. Now, another possible area where biochar could be incorporated is as a supplement to fish feed. And there are a number of studies to suggest that it can lead to increased body weight and survival rate. And this, of course, might be of interest to the aquaculture sector. And of course, when putting biochar into the food chain, care has to be taken to ensure necessary testing and analysis is carried out to safeguard against any less than desirable impacts. So I can't present to you on the topic of biochar without at least highlighting the relatively new concept of voluntary removal, carbon removal marketplaces. And these are increasing in number, visibility, and are being chosen by corporations including Microsoft, Stripe, and Shopify as part of their decarbonisation portfolios. Now, while other methodologies for verifiable carbon sinks exist within these platforms, they all have the use of biochar in common. And just recently, a new fund called Frontiers was announced, a fund of nearly $1 billion that will help fund CD or carbon dioxide removal startups. And these voluntary markets can help biochar production facilities add additional revenue streams for each ton of biochar produced. And that just brings me to my last slide. So we have a growing number of Urbia members actively involved in the space, ranging from bulk biochar producers, product developers, technology providers, consultants, as well as biochar, and indeed marine biomass analytics from the team at Salignus. So to sum up, biochar from marine resources is showing promise, as is the addition of marine resources to terrestrial biochars, or indeed the use of biochars within marine and aquaculture settings. So perhaps you're interested in exploring how your marine-based biomass residues could be used as a feedstock for biochar production, or maybe you want to add marine biomass to terrestrial-based biochars for creation of soil amendments, or perhaps you want to explore how biochar could help by improving the sustainability of your processes. So whether that's through filtering your wastewater to eliminating waste fractions, or maybe you're in need of decarbonized heating source and have access to a large amount of biomass, maybe biochar is worth exploring for you or your organization. So that's it. Thanks for your attention. I've only just barely touched the surface of the possibilities of this developing sector within the time I had. And I hope it served as a brief introduction to the material known as biochar. Now, if you're interested in any more information or you want to get in touch, you can reach me at this email address. So thanks for listening. I'll hand you back to Cliona.
So that was an interesting talk there from Stephen. So before we go back to Filippo, I would like to, I suppose, disrupt this webinar with a presentation on Nua na Mara. So I'm just going to share my screen quite quickly there. I'm sure you can hear me okay.
Yes.
Yeah, no bother. So Nua na Mara along with our colleagues, Mai Britt from the Marine Institute and Maureen Éineacht from úsáid na Gaeltachta, have organised these series of events that you are attending today. So today is our third in a series of 4, so our next one will be in July. But just to give you a little overview of what Nua is. So essentially, Nua aims to bridge the gap in research, innovation and industry through commercialisation. We give, I suppose, support to companies or individuals wanting to form a company in the marine sector in the Gaeltacht area. And of course, if there is anyone on the call today who's looking to get, I suppose, involved in the marine sector, we can signpost you to the relevant agencies or individuals that could be able to help you. So we offer support through mentoring, networking, training, development programs, a link to business development programs, and we offer facilities. So utilising Ras Systems properties, the GTech network that they have, and the link to our research facilities via NUI Galway and GMIT. And I suppose the final part of the puzzle is the funding element. So we link with Ras Systems and give advice on other funding sources, and have a link with venture capitalist networks as well. So not only that, we support a few different industries within the marine sector. So marine technology, pharmaceuticals, nutraceuticals, aquaculture, and value added. So Filippo, I am done with my very short ad on Nua, so I'll pass it over to you to give us a brief update on some interesting projects that might be of particular interest to people on this call that you are involved in before we go to Q&A. So make sure if you have any questions to pop them into the chat and we can discuss there for a few minutes with our speakers.
Thank you very much. Is my presentation visible on the screen?
Yeah,
I hope.
it is. Yes.
Very good. Very good. Very good. Okay. Again, we are coming to the question and answer aspect of the event, which has been a very interesting event. We're also glad to be invited to contribute. As I said at the beginning, I'm here representing Irish Bioeconomy Foundation, and our mission is growing Ireland's bioeconomy together. And that's the motto, and together we can promote the conversion of Ireland natural land resources, land and sea resources. The members are listed here on the right, but I have to say that essentially the majority of the third level organization in Ireland are our members, and the majority of our members are companies, SMEs or larger companies. We've been quite lucky to be involved in a number of European projects as well as Irish ones, and we just picked 2 that we wanted to say a couple of words on for the benefit of the audience, because there are specific opportunities to just be concretely get involved and possibly benefit from it. Of the projects we are involved in 2, I wanted to mention the Bioeconomy Venture one and the Empower Bio one. So Empower Bio, which comes from with the complex name of empowering SME clusters to help SMEs to overcome the value of debt. SME being small and medium enterprise, startups and scale-ups in the bioeconomy. We have been reaching out to most of the clusters in the bioeconomy in Europe, and now we're reaching out again also to their companies and members if they're interested in getting support in accessing investments. This project, as well as the other, are quite active to that end. So in terms of supporting the pitching to investors, supporting connecting with investors, as well as supporting reaching out to larger companies. There's also an ongoing bioeconomy pitching competition where entrepreneurs and inventors can pitch their cases. And that is accessible at this link. So simply so, if you are fundraising for scaling up your technology, your innovation, you may want to check out there. We encourage you to onboard on the accelerator program. We have simplified quite a bit in terms of the onboarding conditions, so we expect that it should take 5 to 10 minutes to get on board. Empower Bio is a project that will be running until the end of the year, and in parallel, we have been lucky enough to be awarded as coordinators for the Bioeconomy Venture project, which has complementary goals. It's mostly focused directly on the startups and the scale up as well. And we are building a platform. We're organizing 46 pitching events, running 3+3 calls for challenges, whereby different companies will issue challenges and different innovators will have the chance to solve them. And as well, we set up an online platform where you can register and proactively promote your own ideas and concepts and innovation for investments into the platform without our direct assistance and moderated by us. So simply, we're providing this link to the Empower Bio and Bioeconomy vendors. I'm sure my colleagues will also be pasting it in the chat. And if I don't see them in the chat, I will be the one posting them soon after. So that concludes my presentation on these opportunities. So let's see. Yeah. So my colleagues will be trying to paste the links on the chat, and I will do that otherwise. Very good. I see them coming now. Good. With plenty of information. Good. Clina, I think it's time now that we move to the question and answers, isn't it?
Certainly, yes. So just
very good.
I
wanted to say one small thing before we call all our speakers. I think it has been a diverse range of panelists, and we had the chance to have Christian Paul giving us a nice overview, and I invite Christian to turn on his camera if he's still there to get ready to take the questions. And I'll say two of these presentations were really about what we use with resources from the sea. Yeah? So making use, one for greenhouse gases emission reduction. So Marie Hayes, who has introduced us to utilizing seaweed for greenhouse gases emission, and I invite her also to turn on her video. And finally, we had a very interesting one from Pauline O'Donnell on sustainability of seafood, and I also invite her to turn on. If anybody has any technical issue, just ring a bell on the chat, but I see all the speakers. Clina, you will be the one calling for questions.
Certainly. So Felipe, have you got any questions for them yourself before we go to one of the questions here in the audience or from the audience?
Yes, from my side, I have 3 or 4 questions. So I'm a bit concerned to start asking all of them now, but I will select maybe one that is a bit simpler to break the ice. It's for Marie Hayes on the utilization of the seaweed. For certain animals, the product of the sea are extremely attractive. So I wonder if there is a coherent response in terms of the cows on the organoleptic side. So is it so that they're particularly appreciated or less appreciated, or it depends? So do we see some strong attraction or less? So that's just to break the ice.
To be honest, the palatability of seaweeds is actually an issue for ruminant animals, in particular, the cattle and dairy cows. So it was necessary within the project, and is necessary because the project is still ongoing, to really develop a process to make it more palatable for the animal. That's been our experience to date. So, if the formulation of the seaweed in the feed ingredient is important as well, because if you exceed, say, 4% of dry matter intake for the animal, you will see anti-nutritional effects, and also that may be due to palatability because they don't like it included at certain quantities of that. So, but we're seeing positive methane effects in the, when we add seaweeds between 1% and 4%. And to be honest, economically, it's probably more viable to include them at lower concentrations than higher concentrations. So, yeah, hopefully that.
Thank you very much. Thank you very much. Any questions from the audience? There will be plenty.
I've put one into the chat room there. Is that okay?
Yeah, so Filippo, there's one here from Noel from FISSTA. And I suppose given looking at the question here is looking at the budgetary sense in the context of new innovation in aquaculture industry. Filippo, if you can have a read of the question there, you could potentially look to direct this to Pauline.
Yes, yeah, thank you, and thanks, Noel, for your question. So just to say that currently the projects that we're working on within the Marine Institute, we're looking at the IMTA production at our research site. So the budgets there are from the Horizon 2020 European Fund. So in the context of sustainability, within these projects and previous projects, there was an impact project run by the Marine Institute before that, and there have been other sustainability projects with regard to IMTA, for instance, the iDream project. These have all looked at the circularity of the IMTA processes and done life cycle assessments. So all of this feeds into how we can best manage IMTA research to introduce it to the industry for sustainability, for the use of the environment, so that the circularity approaches will lessen the environmental impacts. So that's where our current research stands within the Marine Institute at the moment.
Thanks very much. Thank you. That's a good answer. And I posed the question in the sense that the North Atlantic Salmon Conservation Organization, NASCO, where the 19 countries of the salmon, wild Atlantic salmon meet, have looked and monitored all the research projects over the last 15, 20 years. And it's just that I think it needs more coordination in viewing what the EU side party is doing compared to what the Norwegian industry is doing, because there's quite a lot of overlap. Thank you.
I see a hand raised from Christian Paul.
Yes, I would like to ask Pauline a question, because it was very interesting to hear about the IMTA systems. Mm-hmm. But I wonder if you have specific numbers on the reduction of output, like, for example, for nitrogen or phosphorus or carbon or things like that.
Yeah. Okay. So for our production cycle of 2020, we have used literature figures to look at the expected nutrient uptakes for one of our seaweed species. So this was Alaria esculenta. So those findings were based on a harvest of just over 1,000 kilograms of Alaria, bearing in mind we are a pilot scale site, we're not a commercial site. Cool. So the remediation potential we found in conjunction with the other IMTA species, so salmon being our fed species, and then all the other other species on site, we found that the potential for reduction or remediation for nitrogen was approximately 11%. For phosphorus was just over 20%, and for carbon was just over 17%. Okay. So these are very positive figures, and given also that this is a pilot site. So I think that if this was extrapolated to commercial circumstances, I think that definitely the remediation potential is very encouraging.
Sure, thanks.
Yeah, thank you.
Next question from the audience.
Don't seem to have any more, Felipe, so maybe if you wanted to ask your...
Yeah. Sure. I had a quick question for Pauline on the multi-trophic or multi-species aquaculture. I'm not familiar with the details of the authorization of that, but would a double species aquaculture require more authorization, or is the authorization on the site, or is it on the number of species?
Well, currently we hold a research license for the research we carry out in Lenapool. I do know that there are some licenses available for instance, seaweed and shellfish, but as an IMTA license, there currently have not been any issued in Ireland as yet. So unfortunately, we're not that advanced yet, and I think that this is proves the point that the research that we're doing at the moment is very it's on point, and it will show the benefits of this type of aquaculture. And then I would like to see that the licensing systems would become less complex to facilitate the inclusion of IMTA as an alternative to the monoculture that we see at the moment.
Thanks a lot. And more on the general sustainability side, so that for Kristin, personally, I'm been mostly active with the land-based biorefineries, so fermentation, enzymatic or other bioconversion processes, mostly starting from biomass. Hence, I'm quite familiar with a lot of sustainability concepts there that have been pushed. Maybe sometimes we're not sure if fully in good faith, with a lot of sustainability constraints on the bio-based industries that are not in place for the fossil-based industry, for example. So one concept was the land use change, direct or indirect, which of course fossil oil-based refinery in Saudi Arabia has hardly any land use change, while a biomass plantation has. So there is pros and cons of those, good and perfect. It's not always the same. But I wonder if in the marine sector, you have some equivalent concepts on the land use or land coverage. I've seen your presentation showing something about dimensions and space, but those are virtual dimensions. So is there a concept like land use or change or sea floor consumption in the marine sustainability field, as far as you are aware?
As far as I know, there's no kind of normative definition of such, but it could be. I think it could be defined if one wants to, because you can define processes at sea and assess their impact on the sea bottom and the pelagic part of the sea, and then compare these impacts and then define areas that can be used for this and that, and that relates actually to the what's it called, the marine directive on this marine strategies. What is it called? The EU directive that all countries work with at the moment to define strategies, national strategies. So that could be interesting to look with a scientific view into this directive and how it is being settled in various countries these years.
Okay, thank you. Does anybody else from the audience or the panel want to say something? I see a question popping up.
Yeah, I just wanted to ask Pauline if it was possible to, would she have any advice on how we can actually improve the certification of salmon for the organic certification process, please?
Yes, thanks, Noel. Well, I suppose in the context of this talk, we're talking about sustainability, and I think that more pertinent would be the organic certification of IMTA, and this is certainly something that we are looking into in the research projects that we're doing at the moment. And given that the salmon aquaculture industry in Ireland is 100% organic certified, any IMTA that would stem from the highest trophic level species being salmon would certainly qualify as organic status. But because IMTA is in its infancy in Ireland at the moment, we haven't gotten that far yet, but we will be certainly striving towards that.
Okay, thanks very much.
Welcome.
Okay, Kalina, I think we are coming to a fruitful conclusion of the discussion and the session, at least from my point of view. What do you think?
Yeah, certainly. I'd like to thank Filippo for being our MC for today, for the co-organisers, Díríonn and my Brit here, and of course to our fantastic speakers who gave us a great insight, I suppose, into the sustainability of the marine sector and I suppose the definition of sustainability. Christian from DTU has a fantastic wealth of information, and I think if we go to the DTU website, Christian, we'll be able to learn a little bit more as to the work that you carried out over the past while. So gur míle maithagigh chuileanna anseo. Tásúlam gur ócad that you enjoyed and learned something new here, and make sure that you follow our Eventbrite page for the next and final event that will be happening in June based on coastal communities and the marine sector in coastal communities. So